Earthquake prediction remains a complex challenge for earthquake early warning systems, or EEWS. While these systems have shown promise, they often struggle with accuracy and timeliness, particularly in detecting subtle frequency changes characteristic of early seismic activity. Recent research suggests that deep learning techniques may offer a path to improve EEWS capabilities in this area. However, further investigation is needed to assess the effectiveness and reliability of these approaches in real-world applications. To address this, we introduce REAVER, a novel method for real-time earthquake P and S wave prediction. REAVER utilizes Mel Spectrogram representations to capture temporal frequency changes within seismic signals. It employs an encoder-decoder architecture with attention mechanisms to accurately predict the onset of P and S waves upon earthquake occurrence. REAVER consists of 4 layers. Data acquisition layer gathers real-time and historical waveform data, creating a comprehensive model training and inference dataset. 2. Pre-processing layer, in which the signal is segmented into overlapping windows, and each window undergoes Mel spectrogram computation to capture the temporal frequency changes in the signal. 3. Model layer. Utilizing the pre-processed data, this layer passes the Mel spectrogram window to a multi-stage encoder-decoder model to predict the continuous probabilities of P and S waves within the signal. 4. Warning layer. When the predicted probability of P or S waves exceeds a predefined threshold, this layer triggers warnings to subscribers, facilitating immediate response action. Our key findings from benchmarking REAVER against existing methods show significant improvements. On average, REAVER requires only 0.08 seconds from the earthquake waveform to predict the P wave, showing 70 to 95% improvement over existing methods. In addition, REAVER can accurately differentiate between noise and earthquake signals, achieving an accuracy of 98.8% on the test set. This web-based implementation allows users to engage with the system in 2 critical ways: real-time application for continuous seismic waveform monitoring and past earthquake analysis, enabling users and seismologists to study historical seismic data. Let's examine a past earthquake that happened on the US West Coast in July 2018. Here, we see the 3-channel waveform. Z represents vertical earth motion, N represents north-south motion, and E represents east-west motion, along with the Mel spectrogram generated from each channel. Below that, the user sees the model's output displaying prediction probabilities for P and S waves. The system instantly detected the P wave and issued a warning. Subsequently, the more damaging S wave arrives after 10 seconds. The model also accurately identified the S wave, prompting a second warning. The system also allows users to upload their waveforms and run inference of the model on them for further analysis. Now let's apply REAVER to real-time waveforms. REAVER provides a list of seismic networks and stations from which users choose a station for real-time monitoring. We'll select Network 1E and Station BCH1B, a seismic station in Canada. Here's the location of the station on the map. We're now observing the real-time 3-channel data from the station and the model output. The system currently has an all-clear status, but it remains ready to detect any earthquake and provide immediate warnings.